Hi, it's Professor Muldrow once again. And in this video, I'm going to take you through a topic that the author of our textbook refers to as Boolean Zen. Now, the Boolean data type only takes on two values, true and false. Let me explain what Boolean Zen means. If you look at the slide over here, we have a Boolean method named both odd, and it takes two integer parameters. And it returns true if both of the parameters are odd numbers, and false otherwise. Now, what you see here is one way of writing this particular method. So if n1%2, that means if you take n1, divide it by 2, and get the remainder, if that remainder is not 0 after dividing by 2, that's an odd number. So if n1 is odd and n2 is odd, then return true, else return false. Now, the way this method is coded is correct. However, there are easier ways to do it. Let me show you. You could instead define a Boolean variable, which we've done in this case, named test, and set it equal to the result of the test condition. If n1 is odd and n2 is odd, and then instead of if the whole condition, we say if test, because the value of the variable test is either true or false, and that's what we're going to return. But you know what? You don't even need to go this far with it. You can make this even shorter. If the variable test is going to take on the value true or false, and it's contained in a function that returns a Boolean value, there's really no point in even having an if-else. Here are two other ways to write that function. Here we have the Boolean test variable, but then we just say return test, because the value of the test variable is true or false. And since this method returns a Boolean value, that's the value we want to return. So why not just return that? You can even take this one step further. If all you're going to return is the end result of this condition, there's really no need to even bother with a local variable. Just return the condition. Return this, because the value of this is going to be either true or false. This concept is what the author means by Boolean Zen. So in summary, if you have a Boolean method that is structured like this with an if-else, you can rewrite it to just return whatever the test condition is. And it will still work, and I'll prove it to you. Over here on the right, I have code written with three methods in Boolean Zen. First one is tropical depression. It takes a single double parameter, which indicates wind speed. And if the wind speed is between 23 and 38.9 inclusive, that's a tropical depression. A tropical storm is between 39 and 73.9. And if the wind speed is 74 miles an hour or more, you have a hurricane. Let's run this program and see what we get. So suppose I enter a wind speed of, let's say 25. I have a tropical depression because I have a nested if-else set up saying if is tropical depression wind speed. Wind speed is the value entered by the user, in this case 25. So we call the is tropical depression method. In this case, the tropical depression returned true. So we have a tropical depression. If I run it again, This time enter, say, 42. Now I get a tropical storm, because the is tropical storm method gave back a true. The is tropical depression method gave me back a false. But this time, the is tropical storm method returned true. And so I have a tropical storm. Let's run this again. Enter a wind speed of, say, 77. That's a hurricane because the is hurricane method returned true. And finally, if my wind speed is, say, 21 miles an hour, that's invalid because that doesn't qualify as a storm system. That, ladies and gentlemen, is how you do Boolean Zen. Now, I highly encourage you to review the PowerPoint slides, the Chapter 5, Part 3 slides this week. Pay a special attention to the Boolean Zen. Also pay attention to the section in there about De Morgan's Law. That is a well-known mathematical logic principle that you need to know for this week's quiz. If you have any questions, please send me an email at kmuldrow@lbcc.edu.